Hello and welcome everyone. Welcome to another session on problem of 3D. So can I get a confirmation? Okay. Hi. Good evening, Madbar. Hi. So can I get a quick confirmation regarding my voice? Is it clear and loud enough? A quick plus one in chat box regarding the same. Hello, Naikaj. Okay. So can you just give me a confirmation if my voice is clearly audible? Okay, everything is fine. So we are good to go. So we'll be starting this session soon enough. So before starting this session, can I know how many of you were able to solve the uh, problem of the day for the day uh, 30th of uh, the previous problem of the day? How many of you were able to solve the previous problem of the day? Powerful integer. Till then, I'll set up everything and we'll start the session soon enough. Okay. Matbar says he was busy. Okay. कोई नहीं अभी इस सेशन में हम सॉल्व कर लेंगे और यू विल बी गेटिंग अ बेटर अंडरस्टैंडिंग एंड okay, so I have shared my screen. Hi John. Hi. So I have shared my screen. I hope my screen is visible. Okay, so first of all we'll read down the problem statement and then we'll be looking at the test cases and then we'll be trying out brute force and then the optimal approach, right? So let's quickly read down the problem statement. And okay, so let's start. The name of the question is powerful integer and it is categorized as easy. So in this question, you will be given a 2D integer array that contains intervals and the size of that array is going to be n. So interval indicates a starting value and the ending value, and both of them are inclusive in that interval. That is, all the integers from start to end inclusive of start and end are also present, and also we are given an additional integer called as k. So what we have to do, we have to return the powerful integer. So what is the definition of powerful integer? A powerful integer is an integer that occurs at least k times. Okay, so you will be given n different intervals and one more integer will be given to you, that is called k. So you have to find out that which element has been occurring at least k number of times. Okay, so there can be multiple integers that can be occurring at least k number of times, right? So if multiple integers have at least k occurrences, then your target is to return the maximum integer out of all those elements. And there is a possibility, like let's say some test cases are given to you in which the answer is not at all possible. That means no integer is occurring at least k number of times. So in such test cases, -1 should be returned from the function. Okay, so here is our function called as powerful integer in which we need to write our logic. Okay, yes, it's kind of very intuitive. The question requires like a lot of understanding and it requires you to brainstorm a little bit, right? So you can categorize, but over here it's given as easy, so don't worry, we'll try to make the logical part as easy as possible. Okay, so I hope this was clear to everyone, the problem statement. So let me share the other screen and we'll be discussing over here. Okay. Okay. So I have shared one of my screen. Is my OneNote visible to everyone? So I have extracted few of the important points which are given to you in the question. Okay. So I have written down one of the test keys as well, and I have also extracted the important points. So your target is to return a powerful integer. Okay. So from what do you understand by powerful integer? So the definition is an integer that occurs at least k number of times. Okay, it can occur more than k times or exactly k times, but not less than k times. Okay, so if multiple integers are there, then return maximum integer out of all those elements. So this is the important part of the question. Only we need to focus on this much of part. And if the answer is not possible, then one more statement needs to be added. Not possible, then return -1. Okay, so if the answer is not possible in some test case, then you have to return -1. So let's understand with the help of a test case. So I have taken the first test case which is given to us in the input. Okay, so in the first test case, the value of n is equal to 3 and k is given to you as 2. So what you have to do, you have to find out that is there any number that is occurring at least two number of times. Okay, so here are our intervals starting from 1 to 3. I have done using prefix sum approach. That's really great, Nekaj. Yes, you can apply the prefix sum approach as well. Okay, so the first interval has starting 1 and starting 3. So I have written down all the elements that are part of the interval starting from the start and end. So that will contain 1 2 3. The next interval contains starting as 4 and ending as 6. So that will contain 4 5 6. The last interval contains start is 1 and end is equal to 4. So elements are 1 2 3 and 4. So now over here, let's place all of them side by side in this manner: 4, 5 and 6. So now from this you have to figure out, is there any element occurring at least two times? It can occur more than two times, or you can say the frequency of any element, frequency of some element should be greater than or equal to k. Can I see any of the element? Let's see. So over here you can observe 1 is occurring twice. Okay, so its k value given to you is equal to 2. So this frequency of 1 is obviously greater than or equal to 2. Okay, so 1 can be my answer. So 2 is also occurring twice, right? So frequency of 2 is also greater than or equal to 2. Okay, so 2 can also be my answer. So if there are multiple answers according to the question, you have to select the maximum. So 3 is also occurring twice. Okay, so frequency of 3 is also greater than or equal to 2. And what about 4? 4 is having frequency greater than or equal to 2. So I have four candidates as my answer: 1, 2, 3, and 4. And from this all, the largest one or the maximum one is 4. Hence 4 will be your output for this test case. Okay. So in the output, you have to print the maximum integer 4. And this is what the question wants you to find out for any of the input test case. Was the question understanding clear to everyone? A quick +1 in the chat box. If not +1, then mention your doubt. Okay. A quick +1 in the chat box if the question understanding was clear. We can take a look at the second test case as well. If you are willing to take a look, then we can see the example number 2. Let me copy the content of example number 2. Just a minute, and let's quickly solve the second one. Okay, clear. So it was clear. So I think there won't be any requirement for the second or third, but let's copy it over there for our better understanding, right? Okay, so here is our second example. So in the second example, n intervals given to you are 1 to 4. The next one is 12 to 45. The other one is 3 to 8, and the other one is 10 to 12. And the value of k given to you is equal to 3. You can observe over here. So you have to find out any element having frequency greater than or equal to 3. So this will be 1, 2, 3, and 4. And this is 12 to 45. So I'm not writing down all the integers from 12 to 45. Let's say 40. And here is a 45. And 3 to 8. So here I can write down 3, 4, 5. And this can be written farther, right? And here is our 8. And the last one says 10 to 12. So let's say 10 is over here. And this is my 12. Okay. So now I need to find out any element having frequency greater than 3. Okay, so let's see. I can see 3 is being repeated, right? 3 is being repeated. So frequency of 3 is not greater than or equal to 3, right? So what about 4? 4 is also not having frequency greater than 3. What about 5? So 5 is having frequency 1, and nothing is overlapping over here. So all the elements from 5 to 8 are having only single frequency, not even 10, 11, but 12 I can see overlapping between. So this are having two frequency, while the other rest of them are having only frequency 1. So I cannot find any of the integer, hence for this test case the output will be equal to -1, and this is what the question says, and we have to print -1 if the output is not possible. Okay, so this was what the question says to you. Okay, so this is what we have to find out for the question. So now let's focus on how we can solve this question. Okay, so first of all, let's take a look at the brute force approach. If you have any doubt till now, just mention it right now so that we can clear the question understanding doubt in the beginning itself. Okay, so let me copy one of the test case, this one, the first one, right? Okay, so brute force approach, it's like very easy to understand. There's nothing fancy in brute force approach. So in the brute force approach, over here, what you can do, how many elements are there in each and every interval? So I can see, first of all, you need to find out all the elements. Okay, so these are the elements in the first interval. In the second one, 4, 5, and 6 are the elements, and in the last one it is from 1, 2, 3, and this is 4. These are actually all the elements. And now among all the elements, what else do you need? I need the frequency of every element. I need the frequency of every element. So you can, let's say you can generate a map out of it, or you can create a frequency array. But if you are trying of let's say you are trying to create a frequency array, then you need to focus on the size of the frequency array, right? And in the question it is given that the maximum value of the array element can be equivalent to 10 to the power 9. If you take a look at the constraint, it is saying that, let me copy the constraints as well so you will be able to observe. So any interval can have the maximum value, that is the ending part of that interval, can be as large as 10 to the power 9. Okay, it is mentioned in the constraint part. So these are the constraints, right? So I cannot create an array that is as large as 10 to the power 9 because that is not allowable in any of the language. You can at least, let's say maximum 10 to the power 5 can be the size, or around 10 to the power 6 if you are working with boolean and so on. But this is not allowable, right? So I will not create a frequency array. So instead of frequency array, you can use a hash map. You can use a hash map in order to store the frequency of every element in this interval. Okay, this is the entire details about interval, right? Starting and ending point, and find out all the elements and put their frequency in the hash map. So over here, this will be the element and this will be the frequency, and both of them are going to be the integer value, right? So let's create quickly a frequency hash map. Let's say this is my 1 is having frequency 2 is having frequency 2, 3 is having frequency 2, 4 is having frequency 2, 5 is having frequency 1, and 6 is having frequency 1, right? How will you create the frequency map? First of all, you need to iterate over each and every interval one by one. Starting with the first interval, iterate over every element of the interval and calculate their frequency, that is, make an entry in the hash map of their frequency. Similarly, switch to the next interval, iterate over every element and make an entry of their frequency in your hash map. Or if that element is already there, increase the frequency by 1 whenever you encounter the element. Similarly, for each and every interval, you have to do the same thing. And after doing so, you have the frequency map. Now iterate over the entire frequency map one by one. And your k value given to you was equivalent to 2 in this case, right? So check how many elements are having frequency greater than or equal to k. If an element is having frequency greater than or equal to k, then it can be the candidate for our answer. If frequency is greater than or equal to k, it can be the candidate of my answer. But you have to select the maximum one only. Let's say your answer was initialized as, let's say, -1. Initializing -1 because the question says if the answer is not possible, then keep it -1. So I have delivered so much of the information. Like, was it clear till now? Can I get a +1 in the chat box? A response from everyone whether this was clear or not. Till now, was it clear? Till now, any doubt in the brute force approach? Can I get a quick +1 in the chat box? And then we'll move forward, but I need a clarity. Okay, thank you, Madbar. I can see 4 people are watching, so can I get confirmation from everyone? Okay, so just mention clear in the chat box. Okay, okay, so let's begin. So now I need to find the answer. Answer variable is initialized to -1. I will only update answer whenever I find an element whose frequency is greater than or equal to 2. So one by one, iterate over the hash map. So I can see one's frequency is greater than or equal to 2. Yes, so update the answer. So inside the answer, you will place the element. You will place the element. Element is 1. So the next element is also having, and it is greater than the previous one. So update the answer. First of all, its frequency should be greater than or equal to k, and as well as the previous value inside your answer should be lesser than your current element. Okay, because we need the maximum one. Next element is 3. Its frequency is greater than or equal to 2, and it is greater than your answer. It's greater than your previous element. So next element is 4. Its frequency is greater than or equal to 2, and the previous element was 3, and 4 is greater than 3. So update your answer. Next element is 5. Its frequency is not greater than or equal to 2. Next element is 6. Also, it's not greater than or equal to 2. And at the end, just return the value of your answer variable. And this is how I can solve the question in a brute force manner. Why is it brute force manner? Let's analyze the time complexity. So over here, in order to create a hash map, you need to iterate over every element of your interval, of each and every interval. So how long can be an interval? You can observe over here, you can observe that the smallest value of interval will be 1, and the largest value will be equivalent to 10 to the power 9. So assuming that at least 10 to the power 9 elements will be there in a single interval in worst case. So how many at max intervals are possible? 10 to the power 9 intervals. So for every interval, you will be iterating 10 to the power 9 times. That is all the elements of every interval. So overall, how many iterations are done? So this many intervals and this many iterations for each and every interval. So 10 to the power 5 into 10 to the power 9, right? So this will be around 10 to the power 14, and this will give you TLE, because this many operations are not at all acceptable in the given time limit. And assuming the time limit for this question is around, let's say, 1 second, then obviously in 1 second you cannot do this many number of intervals. So this approach is clearly is not going to work, and it is not going to get accepted. Yes, exactly, Madhbar. So was this part clear? Why is this the brute force approach, and why can't you implement and get this accepted? A confirmation in the chat box. Write down clear in the chat box if this part was clear regarding the time complexity. So the overall time complexity you can write down as n into the range of every interval. So you can write down as order of for every interval, that is there are n intervals, and for n intervals you will be having an iteration over the entire range, and the space complexity will be equivalent to the, at max, the entire hash map will be containing all the elements from 1 to 10 to the power 9, and let's say it is equivalent to the range or the maximum range. So this is going to be our time and space complexity, and this approach is going to give me TLE, so I will not be able to implement this. Okay, thank you for the confirmation. So now how can you optimize it? So over here, there are some of the observations, and with the help of those observations, I'll figure out some of the, let's say, an approach. So let's observe how we can optimally observe it. Okay. Approach number 2. So let's take the same example because it is a smaller test case, and it will be very helpful for us to dry run, and it will be easier enough, right? So now over here, the problem was that I was iterating over the entire interval, right? I was iterating over entire interval. Does not matter if that interval elements are repeating or not. So now, in order to solve this question, first of all, you can take the advantage of frequencies. Okay, so how will I take the advantage of frequencies? First of all, let's say uh, if the range was small enough, let's say such a range, let's say if the range given to you of any interval at max was equivalent to 10 to the power 5. So this is feasible, right? You can create a frequency array of this size. If this was the interval range, that is from 1 to 10 to the power 5, if this was the range, then it was possible to create a frequency array. Okay, so let's say I worked on the frequency array, assuming that the entire question says gives you a feasible frequency array. So now let's say this is my frequency array elements 4, 5 and 6. So instead of iterating over entire interval, I will simply write down the frequencies of the starting and ending point of the interval. Okay, so what I will be doing for the starting point, whenever I encounter the start, frequency of the starting point will be increased by 1. And for ending point, what I'll be doing, I will be incrementing the ending point by 1, and I will be decreasing its value by 1. Okay, so this is something different from what actually we used to do, but this is what I am going to do in order to store the frequencies of the starting point and the ending point of ith interval. So let's populate this frequency array with the help of this part. So what I'll be doing, starting for each and every interval, the intervals, let me remove the brackets. Okay. So starting has 1, 4 and 1. So all of them will have frequency 1. So let's increase the frequencies. So one's frequency will be increased by 1, and I can observe 1 occurs twice in the start. Okay, so basically you will work method one by one, iterating over every interval. Let's one by one go through all the intervals. Okay, the first interval, start is 1, increase the frequency by 1. End is 3. So what I said, end plus 1, that is 3 plus 1 will give you 4, and decrease the frequency of 4 by 1. So decreasing it by 1. So it will be initialized to 0. Now it is minus 1. 0 minus 1 will be minus 1. Next interval, starting point is 4. Increase the frequency by 1. So increasing the frequency of 4 by 1, it will give you 0. It will give you 0 because it was minus 1 earlier. And now this is ending point 6. 6 plus 1 will be 7, and it decrease the frequency of 7 by 1. Let's say the frequency array was large enough, so it will be having minus 1. So the next element is, next interval is 1 to 4. So starting point is 1, increase the value by 1. So increasing the value by 1, and I can observe it will be 2. And the ending point is equivalent to 4. So for ending point, 4 plus 1 will give you 5. So decrease the frequency of 5 by 1. So this will be minus 1. So this is my frequency array. So now I will apply the prefix sum on this frequency array. Why prefix sum? Because you know that over here, in order to store the frequency, I only targeted on the starting and the ending point of every interval. But there are test cases possible. There will be test case possible in which the answer will not always be either of the starting or the ending point of an interval, right? It is possible that, let's say, there are this kind of intervals given to you, and in this kind of intervals, let's say this was interval, let's say 1, this is interval number 2, and let's say this is the starting and the ending point, and these are the elements. So an element, let's say over here, this is an element which is overlapping in both of them. This big is the second interval, and this is my first interval. Over here you can observe that, let's say, the maximum element is possible, and that maximum element is not the starting and the ending point. There are test cases possible. If you tried solving different test cases, you will observe that there are possible test cases where the answer will not always be the starting and ending point of an interval. It can be in between. Yes, exactly. So how will I handle that part? So that part will be handled by taking the prefix sum of the frequency array. So let's take the prefix sum of this frequency array. Initialized, This has been initialized with 0. Okay, so wherever you see empty, just imagine 0. So now I'll be taking frequency arrays perfect sum 0, 1, 2, 3, 4, 5, 6 and 7. Okay, so this will be 0. 0 plus 2 will be equivalent to 2. 2 plus 0 will be 2, and 2 plus 0 will be equivalent to 2. 2 plus 0 will be 2, minus 1 will be equivalent to 1. 1 plus 0 will be 1, and 1 minus 1 will be equivalent to 0. Okay, so what are these values? So as I said that this is the frequency here. It denotes how many times this element is occurring in the interval, right? In the entire interval, what is its frequency? In every interval, the total frequency is denoted in my frequency array. So over here as well, if it is saying that 2 is occurring twice, then that means you can observe over here. This is what I have stored. 2 is occurring twice. 3 is occurring twice, then at index 3 in the frequency array, 2 will be present. You can observe over here. You can observe over here. And for 1 as well, in every interval in total, this 1 is occurring twice. You can observe its frequency has been updated. Similarly, for 4, it will be 2 in the frequency array. You can observe. For 5 and 6, it is 1. Let's observe. You can observe 5 and 6 are occurring only once. So this is how you can handle the in-between part of every interval. Okay, so I have handled the in-between part. Now what? Now you can iterate over this frequency array. So we worked on the hypothetical part of this question. I reduced down the constraint from being as large as 10 to the power 9. So I reduced it down to 10 to the power 5 because I wanted to show you that if I'm taking the advantage of my frequency array, then with the help of prefix sum, I can somehow figure out a solution. If this was the interval range, then this solution is feasible enough. But this is not my interval range. What is the interval range? Interval range is from 1 to 10 to the power 9. So first of all, frequency array creation cannot be done. And let's say you created a frequency array. Let's say you invented a language in which frequency array can be created and its size can be as large as 10 to the power 9. But what about finding the largest element? You need to iterate over the entire array. That is, you need to have 10 to the power 9 iterations. And this many iterations will obviously give you TLE. So now what can I do? If this is not possible, then what can I do? See, in order to find the answer, I need the maximum answer. That's why I need to iterate over the entire frequency array. As I need the maximum answer, that is the reason I need to iterate over the entire frequency array. Let's say I had some kind of data structure. I had some kind of data structure which can easily give me the maximum value. It can easily give me the sorted part. Let's say I had a data structure in which I was able to store key value pair. Over here, you need to store a pair, right? Because you need to store the element as well as its frequency. There was some data structure in which that data will be stored in a sorted manner. Let's assume in increasing order of its frequency. Let's assume. So what I'll be doing, let's say I will be using that data structure. Inside the data structure, 1 will be having frequency 2, 2 will be having frequency 2, and 3 will be having frequency 2, and 4 will be having frequency 2, 5 will be having frequency 1, and 6 will be having frequency 1. So till now, was it clear? Can I know from the audience whether you are able to understand what I'm trying to deliver or not? Can I know whether you are able to understand? Can I get a quick confirmation in the chat box? A +1 in the chat box will help me a lot. Okay, so I got a confirmation from Malbar, and okay. Okay, so that data structure will help me to, okay, got it. So that data structure will be helping me that, okay, you don't need to iterate over entire array. I'll be helping you to get the answer soon enough. Okay. But then and also then, if you are iterating over entire range, if you are iterating over entire range that is from 1 to 10 to the power 9, although this data structure will give you the sorted ordering, but this is not going to work. What I'm trying to say, if you are working on this entire range, if you are working on this entire range for every interval, then this data structure will also not be useful, because that is somewhat similar to brute force. In a brute force manner, if you are finding a maximum element, that can be done in a linear time. So what is the benefit of sorting the data? There is no benefit. So I need to somehow figure out a technique that, with the help of the starting point and the ending point of the interval, with the help of the starting and the ending point of the interval, I can also handle in between elements. I can also handle in between element. If the answer is an element between this range, then and also then just storing the data of my start and end for an interval will be sufficient enough. So I need such a technique. So what I'll be doing, I will not be storing the frequency of every element. I will be only storing the frequency of starting and ending point, and also storing the frequency in this manner. For starting, I will, for starting of the interval, I'll be storing its frequency by simply increasing the value by 1. Okay, that's it. And what about the ending point of an interval? So this is, let's say, interval, and this is my starting and ending point. For ending point of an interval, I will increase the frequency, I will decrease the frequency of end plus 1. Let's say your starting point was 3 and your ending point was equivalent to 5. Okay, so I am doing this thing in order to handle in between elements. Okay, as I already mentioned this part, I'm doing this in order to handle in between elements. So frequency of n plus 1 will be reduced by 1. Okay, this is what we exactly did in frequency array, right? In prefix sum in this part. So I'm doing that same thing, but without creating a frequency array. Okay, and in order to store this data, in order to store the key value pair, that is element and its frequency pair, I will be using tree map. As I mentioned, I need the data, I need the maximum element, right? So I'll be using the tree map in order to give me the answer in a very sorted manner, so that no sorting will be required. Okay, no sorting of the element will be required. To be precise, I need the element to be maximum. Okay, if the elements are in sorted manner, then this will be helpful to me, right? So now over here, after doing this thing, let's say I have created a tree map and I have stored the data. And now I'll be storing only the starting and the ending point. Let's take this test case. Just let's copy it quickly and let's get this solution done. So here is our test case. So as I mentioned, I will be storing. Okay. So as I mentioned, I'll be storing its frequency in this manner for every interval. Okay. So let's clear this part quickly and let's get this done. So the first one is this 1, 2, 3. Okay. So starting point is this one. So I'll be storing frequency of 1 as 1. The end point is 3. So as I mentioned, 3 plus 1 will be giving you 4. Follow this part. And I'll be storing the frequency of 4 as minus 1. Because assume if the element is not in your tree map, assume the frequency to be 0. So 0 minus 1 will be minus 1. Next element is 4. It is the starting point. So store the frequency of 4 as 1. It is not present. So it is already present containing minus 1. So increase it by 1. If it is already present, increase it by 1. So it will be 0 now. And now for 6, this part, 6 plus 1, I'll be storing the frequency of 7. Decrease it by 1. 7 will be having minus 1. So moving on forward, next element start is 1. So increase the frequency of 1 by 1. This will be giving you 2. And the ending point is 4. Decrease the frequency of 5 by 1. 5 is not present, so 5 will be having minus 1 as its frequency. So I populated my entire tree map to find out the answer. For this test case, we already know the answer is 4. But how? So now over here, in order to handle in between elements, whenever I will be taking the help of the prefix sum as well, I will be taking the help of my prefix sum. Let's say I have two variables, prefix and answer variable. Answer variable is initially -1 and prefix sum, this prefix variable will contain prefix sum. Okay, and here is our sorted manner, 1, 2, 4 and so on. So now what I'll be doing, one by one, I will be taking an element from my prefix sum. Okay, so one by one I'll be taking an element from my tree map. Sorry, not prefix sum, from the tree map. Okay, so tree map has sorted the elements. Okay, so in which manner? First of all, you need to understand the tree map will be sorting the elements in which manner. Can I know from the audience that if you are using a tree map will sort the elements in which manner? Based on key or based on value? Can I know from the audience? Tree map sorts the uh, pair based on the key or based on the value? Anyone from the audience? Okay, so tree map will be sorting based on the key. It will be sorting based on the key. And over here, our key is equivalent to the element 1, 4, 5, and 7. So let's place it in a sorted manner. So let's this will be in this manner. Okay, they will be sorted based on your key value. Okay, tree map will be sorting based on your key value. So this is my sorting, and now we can apply our prefix sum. So what I'll be doing, whenever I see the frequency, one by one I will be, yes, exactly. Whenever I will be, one by one I will be iterating over the elements of the tree map. First of all, 1, 4, 5, and 7. So whenever I see the frequency of the element which I am seeing is positive, that means is greater than or equal to 0. If this is the case, then what I'll be doing, first of all, I will increase my prefix sum by the frequency of that element. Okay, I'm doing the same thing which we saw over here. From frequency array, I created this prefix array, right? But not creating a prefix array. So this is what I'll be doing with the help of a variable. And now what I'll be doing, I will be checking whether the value of that element, I mean the prefix value, is greater than or equal to k or not. So this is how you will be handling the in between elements. If the prefix sum value is greater than or equal to k, then that element will be a part of your answer. So after increasing the value of prefix by the frequency, if the value of your prefix sum is greater than or equal to k, then update the answer by that element. Over here, if you were iterating over the entire prefix array, over here you were iterating over the entire prefix array, but no prefix array is present. So whenever your prefix sum is greater, update the value, update the answer by your element. Okay, so this is handled without creating a prefix sum array. And what about the element frequency being negative? Actually, the frequency cannot be negative, but here this actually is not the frequency, it is the value. It is the value. Okay, so I'll be writing and let's change it down to value so you won't confuse yourself. Okay. It is the same thing that we did with the help of the frequency array and prefix sum of that frequency array. If the value is negative, if this value is negative, if the value is negative, then what I'll be doing? Here you need to handle in between part. In between part. So how will I handle in between part? So if the, first of all, I will compare the prefix. If the prefix value is greater than k, then I will update the answer. I will update the answer by element -1. Why element -1? Because over here, while storing the frequency, what I will be I did for the endpoint of an interval? I decreased the value of endpoint plus 1. If my endpoint was equivalent to 9, then frequency of 10 was decreased by 1. 10 was decreased by 1. Right? So in order to redo this thing, I will be first of all checking my prefix. If prefix value is greater than or equal to k, then your answer will be element minus 1. Okay, and if and after doing so, I will increase my prefix sum. I will increase my prefix sum. I will increase my prefix sum by the value of that element stored inside my tree map. Okay, so this is what I'll be doing. So let's see, is this helpful in order to solve the question or not? So first of all, let's one by one go through each and every element in my tree map. Prefix is equal to 0. First of all, I will take 1 and 2. This is my element and this is its value. Prefix, so if this value is greater than, this value is positive, so increase the prefix value. So prefix will be increased by whatever is the value, so prefix will be equivalent to 2. Now you will be checking if the prefix value is greater than or equal to k or not. Yes, it is greater, so update your answer. So answer will be updated by the element is 1 right now. Okay, so let's take the next element. Next element is going to be 4 comma 0. Element and this value 4 comma 0. Okay, so the value is positive or 0. If the value is positive or 0, so first of all what I need to do, increase the value of prefix. So 2 plus 0, 2 plus 0 is equal to 2. And what is answer? Should I update the answer? Take a look over here. Prefix is greater than or equal to k. Yes, so update your answer by the element is equal to 4. So update the answer. Let's take the next element. Next element is this one. This is the next pair, that is 5 and minus 1. So value is negative. So for negative I will be handling in this manner. The value is negative. First of all, check the prefix. Okay, so is the prefix greater than or equal to k? Yes, the prefix is greater than or equal to k. So your answer will be element minus 1. Current element is what? Element is 5. So your answer needs to be updated by 5 minus 1 is equal to 4. It is already 4, so no updation required. And at the end, after doing so, just increment the value of your prefix by value. So value, that is minus 1, will be added to your prefix. So 2 minus 1, 2 minus 1 will be 1. Let's take the next element. So the next element is 7 and minus 1. Okay, so now the value is negative. So let's take a look at this part. If the value is negative, compare prefix and k. So prefix is 1 and k is 2. So 1 is not greater than or equal to 2. So answer will not be updated. So what? Increment the value of prefix by the value of element. So value of the element is minus 1. So increase the prefix by this value. So value will be, prefix will be 0 in this case. So now are there any elements remaining in your tree map? No, nothing is remaining. So whatever is your answer variable's value needs to be printed in the output. And this is how you can convert the entire frequency array and prefix sum logic into variables, and this is how you can find out the answer. Okay, so I handled the in between elements. I avoided the creation of the entire frequency array. I avoided the creation of entire prefix sum frequency array. So this is with the help of variables and with the help of a tree map, I was able to store the frequency. I was able to handle in between elements if they are a part of my answer. And this is the entire logic. Was this part clear to everyone? Yes or no in the chat box? Can I get a +1 in the chat box? And then we'll take a look at the coding implementation for the same. Okay, I will show you the code snippet because it's already more than 45 minutes. So I will not take much of your time. Okay, we can code as well. Okay, so do you want me to code? If you want me to code, I can quickly code down the solution, or you will be okay with the code snippet. Okay, it's your call, completely your call. Can I get a confirmation regarding that thing? regarding that thing, What do you want? No code. Okay, so you want me to, I mean, no code means you want me to code, or you don't want to see the direct code. Okay, so let's code it down. No code. Are you writing down, Madhbar? Anyone? Okay, so let's code it down. No? So first of all, you need a tree map. Okay, so I'll be simultaneously writing down the algorithms as well. Okay, so first point is to get a tree map and calculate the frequency of starting point and ending point. Okay, so I guess my screen is visible to everyone. Okay, so I need a tree map to, and over here you might be wondering why I was not using the hash map, because you cannot store the elements in a ordering inside your hash map. Hash map does not maintain any kind of ordering, right? Okay, so okay, I got the message right now. So let me just share the code. Okay, I have added some of the comments as well. So here I have created a tree map, not hash map, because hash map does not maintain the ordering. Tree map will maintain the ordering in sorted manner for the key. Okay, so this is my tree map. This is how you create tree map in Java. And now for every interval, its starting point, what I'll be doing, I will be storing its frequency, that is +1. I'll increase the frequency of the starting point. And for ending point of an interval, what I'll be doing, I will not be targeting the ending point of an interval, but end +1, the element after end, I'll be decreasing its frequency by 1. Okay, and now here is our iteration over the entire interval array. So this thing will be implemented in this part using the for loop. So this is my starting point of the interval, ith interval, and ending point. And now inside the map, I will make an entry of starting point. If that value is already present, then increase and fetch that value and increase it by 1. So this is map, this function get or default. What this function will do, it will look for the value start inside your map. If that value is present, if that key is present, then its value will be returned. If that key is not present, that is, if start is not present, then its default value will be taken as 0 and entry will be made inside your map, and that 0 will be returned by this function. So 0 plus 1 will be 1, and this put function will override the previous one, that is previous value of your start. Same thing for end plus 1. I'll look for end plus 1. If this end plus 1 is present, then decrease the frequency. If it is not present, take its default value to be 0, and 0 minus 1 will be -1. So tree map has been populated in this part. Now take the prefix sum and answer variable. So a prefix sum variable, over here you can take it as integer. Why integer? Because this value cannot be beyond what? So first of all, observe, can is it required to take this value as long or not? So you can observe over here that interval, no matter how long the interval is, but any element cannot have frequency greater than total number of interval, greater than n. Any number cannot have its frequency greater than n. So this prefix sum is the summation of frequencies, right? So it cannot be greater than n. Okay. So now over here, this is my answer variable initialized to -1. Now one by one iterating over the element of my map. So I have fetched the entire set of keys with the help of key set method. It will return, and one by one iterating with the help of for each loop. So here this statement was for printing. Okay. So now frequency, or let's say this is called the element value. Let me change this part to value. Okay, so if this is what I have fetched from the map, the value of that element, and if the value is positive, first of all increment the prefix sum, and then check if the prefix sum is greater than or equal to k or not. That is, sum of the frequencies is greater than or equal to k, yes or no. If yes, then update your answer variable, else move further, right? If the value is negative, then in order to handle in between elements, you will first of all check the prefix sum. First of all, check the prefix sum. If that prefix sum is greater than or equal to k, then update the answer by element minus 1. You stored element plus 1 and decreased its frequency by 1, right? So over here, you are redoing that thing. And at the end, increment the prefix value by the value of that element. So after this for loop iteration is complete, your answer will be inside your answer variable. So now let's compile and run and let's see what can be the. Okay, and let's also simultaneously take a look at the. Okay, so let's take a look at the so-called time and space complexity. Okay, so let me clear it out. Tree map has an internally implemented self-balancing binary search tree. Okay, self-balancing binary search, all the operations are done in log n. So now over here you can observe this put operation. This operation will take log n of time. Both this put operation will take log n of time, and fetching an element will also take log n of time. That is looking for an element. So this outer for loop is running n number of times. So this for loop will take n into log n plus log n. So you can write it down as n log n time. This will take n time. This will take log n time. Okay. So this outer for loop, this for loop will take log n plus log n multiplied by n. So this outer for loop will take n into log n plus log n. Okay, and over here this is a simple iteration over the entire element. So this is going to take order of n time because you are only iterating over the entire interval. So let's say interval is denoted as 10 to the power 9, right? So I'll be taking the interval as, let's say, n, or range. Let me call it as range instead. This will be iterating interval range, the maximum interval range. And this n log n is greater value than the interval range. So the overall time complexity of this approach will come out to be order of n log n. And what about the space complexity? You are using a tree map, and the tree map can contain elements equivalent to the interval range at worst, that is equivalent to 10 to the power 9, but not over here. Why? Because you are only storing the starting and the ending point. So this will not occupy the space equivalent to interval range. It will occupy the space equivalent to 2n. What 2n? Because each and every interval has starting point and ending point. I'm only storing two values for every interval. So the space occupied will be order of 2n. And over here, this for loop will run order of n times. So the space complexity comes out to be order of n. It is linear. So now let's try to submit and see what do we get. Okay, and the solution has been accepted. So let me share this same solution in the chat box as well. So you can refer it down whenever you try this question on your own. Okay. Okay, so pasting it over here. I hope this was clear to everyone. Do you have any kind of doubt, any confusion? Then just mention, or else we'll be ending the session here only. Okay, so once again, try using different test cases. Try to solve this question again. So you'll be getting a better and clear understanding of what actually the process we have discussed till now. Okay, so I hope it was clear. Okay, thank you. It was clear to Madbar and everyone else. Okay, so we are ending the session here only. It was great interacting with everyone. Okay, so I'll from the next video today, I will just go through the important and increase the speed. Okay. Okay, so thank you for joining, and do like this video if you really enjoyed the session, and do share with your friends as well. And if you have any doubt after the session, then you can mention in the comment section as well. Thank you everyone. Thank you for joining. Bye bye.